Everyone, thank you very much for joining this month's installment of the TBC Power Hour webinar series. Today, August 25th, we'll be walking through an introduction to the MX50, the new mobile mapping instrument, and TBC with the focus in asset management. So we'll kind of, in highlighting this image here, we'll kind of walk through a data set, get you all registered with that mobile mapping data, walk through some of the tools that you can go ahead and collect data from and turn in some of this point cloud data into real life asset tools, and then ship that data out to GIS to track in an asset management geodatabase, essentially. Oh, skipped one. Here we go. The presenters today will be Skylar Newmeyer. Skylar, do you want to give a quick introduction of yourself?
Yeah, sure thing. If anybody listening is a Trimble mobile mapping customer, you've probably met me for a training or a demo or something like that. I worked on the final testing for the MX50 and a couple years ago on the MX9, and mostly focus on kind of specialty applications of mobile mapping systems here at Trimble.
Awesome, thanks, Skylar. And then next up, we have Nicole Lim, who will be demoing all the GIS demonstration today. Nicole, do you want to give a quick introduction?
Yeah, for sure. So hi, everyone. I'm Nicole, and I'm the TBC QA testing engineer. For 550, I tested the support for ArcGIS Pro with TBC.
Awesome. Nicole's based out of Calgary, from the University of Calgary in Alberta. I'm happy to have Nicole on the webinar. Myself, I'm Jeff Ryan. I'm the product manager for Trimble Business Center and Survey Office. I think that's probably most of you on the call, but thank you everybody for joining today. If you have any questions throughout the webinar, please shoot them in the questions box, or any sort of troubleshooting. We can try to help you out with audio issues, or just answer your questions throughout the webinar. We will be taking some questions at the very end as well. And just a quick note, if we don't get to your questions, we will be getting back to you via email later on once we generate the report. So thanks again for joining, everybody. We hope you find this insightful. With that, I will go into the agenda for today. So the first thing, Skylar will walk you through the MX50 import and trajectory processing in TBC. Then he'll go through the run-to-run registration process. And then we'll show how to collect some of that data, right? What I was talking about earlier with all this point cloud data. How do we extract points and linear features from that? Then we'll go into the GIS connection and walk through all the updates that happened in the past couple of releases. And Nicole will demo that, kind of writing data from TBC to ArcPro, and then making some changes in ArcPro and writing that data back into your TBC project, holding that symbology, which is really nice. Good changes there in the past few releases. And then next we'll go through the TBC resources slides, and then tease the next Power Hours. So the next one in September is going to be an exciting one. And then we'll take some time to answer some of your Q&A. With that, I will go ahead and flip it back over to Skylar.
Sounds good. Thanks, Jeff. Okay.
See your screen.
Perfect. Well, hello everybody. If any of you have joined me on the last MX9 Power Hour, there's a little bit of overlap on this one, but the kind of main difference is the system we're using. The last one was the MX9, which is kind of our top of the line engineering system. And then this Power Hour will be focusing on data from the MX50, which is our new kind of mid-range system, which is still applicable to some engineering work, but is more kind of focused on this GIS level work, asset management, road surface conditions, things like that. We'll be looking at a different workflow than we did the last time, and I'm gonna highlight a few of the new kind of features, new tools in the last couple of releases of TBC. I'll still go over the entire workflow and kind of work this left to right workflow that I talk about a lot, but we'll kind of skim over some of the stuff that's been around a bit and dive in a little bit more to the newer things. So what you can see right here on my screen is just a standard plan view with my mobile mapping trajectory and my 2 runs highlighted. If any of you have used any Trimble mobile systems before, you know the MXDB is all I did. So at this point, all I've done is just drag this MXDB right in and drop it there. The next step that we're going to do to highlight the new trajectory processing that's in TBC is bring in my base station. So I'm just going to bring in a base station, and you'll see the same screen that you would normally see when you have a base station in TBC. So let me turn on the background map. You can kind of see we're in Colorado. This is during some of the testing pre-release of the MX50. I have a base station up here in Fort Collins, and then our collection was down here in Longmont. A little backstory on why I have a base station so far away is that was one kind of part of the test that I was doing at the time. And two, we had a couple core stations that were closer by, but they were actually recording at lower rates for the time period that we needed. One was, I think, at a 5-second rate, and one was at a 30-second rate, where COFC up here in Fort Collins was recording at a 1-second rate. It also included GPS, Galileo, GLONASS, and I think Beidou. So it is a longer baseline than we would generally recommend for a mobile mapping job, but the bases that had a shorter baseline would be more detrimental by having those slower update rates. So short baselines are important, but 1-second update rates are more important. So that's why we use this base. Knowing that these bases weren't recording ahead of time, you know, if I did my due diligence, I probably should have set up a local base, but this was just kind of, we're mostly looking at horizontal accuracy on this one. GIS level accuracies were our goal. There's no control targets, so we didn't worry about it too much. So you can see here's my mobile mapping run down here, and then our base station up here. All I did was drop them in, and then I'll move into the next step. We're always going to take this left to right workflow that I've kind of harped on, and if I've had demos with any of you, you've probably heard me say it before. So the first thing is going to be change your coordinate system. You can see I already have it set as Colorado Central. The next thing we're going to do is select our mission right here, and you can see when the mission is selected, some of these buttons become active. The thing I want to focus on for a minute here is this process raw trajectory data command that's relatively new. It's actually kind of a built-in version of POSPAC. So it's the algorithms that are running are POSPAC algorithms. It's actually feeding a batch file over to POSPAC and then getting the return from POSPAC. The idea behind this tool was not to 100% replace POSPAC. At least in this first iteration, we wanted to keep it kind of simple, replace the tools that you needed every single time you're in POSPAC, but there might still be corner cases where you want to go in and get some more advanced options that are in POSPAC that we haven't added yet, get a little bit more flexibility on how you process. The idea is we just want to take care of normal jobs, you know, let's call it the 90% of your jobs that are just standard. We wanted to have all the tools you needed for those in here. Now that this tool's open, I'll kind of walk through the list of what we've got here. The first thing is going to be your GNSS and inertial raw data folder. It'll generally find it automatically. I have a bunch of versions of this project because of the Power Hour. You can see here I have a bunch of different TBC projects. So I'm just going to go in and select the raw folder for it. And then this SBET output folder, it'll automatically generate a nav-pros folder. But you can also just export this wherever you want to. It's just where you want your final exports to go to. You can see available reference stations. I only have a single base on this one. If you had multiple bases, you can turn them on and off. You can have, you know, multiple time periods for a single base, and they'd all show up in this list here. It shows the file path to them, and then you can turn them on and off. We can cut off timing at the start of a trajectory, which the main reason for that is if, you know, you started a mission a little early, there was still movement in the vehicle, you're static at the beginning of the job, your kind of static period is you know, interrupted or disturbed by the movement of the vehicle, you can trim that off. Cutting off at the end, let's say somebody, you know, doesn't end a mission, you have a bunch of data that you don't really need and you don't have base station data for that time period, you might want to trim off the end time of the mission. We can turn on and off GAMS and DMI, which if you aren't familiar, GAMS is the secondary antenna that we can use to improve heading in certain situations. And DMI is a wheel-mounted odometer that can, one, trigger a stationary position. When it senses that things are stationary, it can lock it, such as at a stoplight. The other reason for DMI is for completely GNSS denied environments. It allows us to still get a distance and use dead reckoning. For this project, I was testing with no GAMS or DMI, but if you do turn them on, you can change your lever arms or the standard deviation, so how much you trust those measurements. The initialization mode gives us the same options that you'd see in POSPAC. I'm going to set just gyro compassing for this one since I wasn't planning on using GAMS. You can see we have purely GAMS, gyro compassing, GAMS and gyro compassing, or VNAV. We're going to go with just gyro compassing for this one. The antenna manufacturer and antenna type are automatically set based on which type of data you bring in. So if you bring in this case, the MX50 and the MX9 both have the same antenna manufacturer and type, but we do plan on if that changes, it just automatically reads it from the MXDB. Then we also have multipath options. You can set high, low, medium, and then I check this box for generate the QC report. So it's pretty simple. Hopefully this kind of covers what you need every day. Currently, with this kind of first iteration of our built-in trajectory processing, you still need POSPAC installed on the computer. So since, like I mentioned, it's kind of feeding data over to POSPAC and then getting a return, you don't have to open it, but it still is installed. And so you'll still always have POSPAC there as kind of a backup if you need some of the more advanced features. The longer term plan is to get a more advanced integration, but for right now, this should kind of cover the majority of jobs. So what I'm going to do now is I'll press compute and let it run. It takes it a few minutes, and while that's going, I'm going to switch over to a different project and show the next step, and then we'll look at the QC reports once it's done. So I'll press compute, and it's going to start going through all the normal steps that you would have seen in POSPAC. So when you set a base station in POSPAC, when you bring in your raw POS data, when you set base station as your primary, all of those steps are just kind of happening in one go here. You can see we're importing data at the moment. So it takes a little bit longer, but it's all just one step instead of 4 or 5 different steps that you'd normally be seeing. So while that's going for a few minutes, I'm going to just open this next project up. This is the same project. It's just been generated, so let me move over here. So what I did after that was it automatically changes your primary trajectory to your SBET that you just generated. And then all I've done is generate scans. So I wanted to open that up and discuss that for a second while we're waiting for the QC plots. So generate scans, it's the same as you've seen with the MX9 if you're familiar with that system. Hit next. I wanted to stop and talk about filters for a second because we do have some different options for filters. We have less options under the advanced filtering settings, but we've spent quite a bit of time on the presets. So I wanted to discuss the 2 different presets. The default preset uses the firmware flags that are filtered on the actual system during collection. Things like high amplitude, isolated points, points outside of its range. All those are flagged during the collection. The default filter uses what flags the system did and then removes those on processing. So it adds 0 time to the processing to use the default filters versus not filtering at all. It doesn't take any significant amount of time, and it takes care of the majority of situations is kind of how I describe it. Is it works pretty good. There is the chance that some good points are removed, primarily on power lines and kind of certain isolated features. And because of its over filtering on occasion, that's the reason we put in this high quality filtering option. The high quality filtering option is actually TBC doing the filtering. The way it works is, it sees the flag points, but doesn't remove all of the firmware flag points and goes through on its own during the processing and does its own filtering that will take a bit longer and get us a little bit higher quality. So it's kind of a trade-off that we wanted to allow the user to select between where, hey, I don't mind if there's a little bit of noise or a handful of points removed that shouldn't have been. I just want to get my points ready. If you process in default, you should be able to generate scans in about half the collection time or a little bit more than that. So an hour collection is usually 30 to 40 minutes to process. High quality filtering will add some time to that if you have the time, but will give you a closer to finalized point cloud when you're done with it. Then here, scan configuration is the same as any of the other mobile systems. You select your trajectory and can colorize and generate your masks here. We did do some improvements on the colorization accuracy for the MX50, which I'll discuss when I show the colorized point cloud. I'm gonna open up the QC plot. So I don't know if you guys saw the little notification, the GNSS processing finished while I was talking, and it generated the QC plots here, which if you guys are familiar with POSPAC, you'll recognize that this is the same screen from POSPAC. We kind of took a poll of different people at Trimble and some customers. Everybody seemed to kind of like the layout of these display plots that POSPAC did. So we kind of thought if it's not broke, we don't want to try to fix it. We're just going to move that over and allow you to use the same plots that everybody's familiar with. The three most common plots that we kind of first take a look at are our position error RMS values. And a little tip that I didn't know at first is if you shift click multiple plots, right click and say display selected, you can view them all at the same time. Let's zoom in on our area of interest. You can see our vertical is, just a hair over 3 centimeters. Most of the time we're kind of in the high 2 centimeter range. And then our horizontal is, between 1.6 and a peak of 2.2. So that's kind of what we're looking for with this system. Of course, ground control could improve this. As you'll see in this job, it does have some trees. I don't want to promise any kind of accuracy on any particular job, but this was just, I would call this an average job. It wasn't particularly open sky and easy, and it wasn't particularly hard and downtown or anything like that. One other little tip that I like to show is if you go to view, plot markers in either event 1 or event 2, those will turn on markers at the camera trigger locations of the system. If I open that back up, you can see all these markers that show where you were actually collecting data. So you can focus on just the area of interest. You can see, I drove for quite a while after, and you can see these spikes over here. If I had like these spikes and I was worried about them, I could know that they're not important because they're not part of my actual collected run, as you can see over here. And you have the same exact options. So if there's any other plots that you guys generally are looking at, you can check out your solution status, calibrated installation parameters for your DMI and GAMS lever arms, all those. There's a ton of plots in here that you can look at, and they're all the same as if you had processed in POSPAC instead of processing in TBC. Close that real quick. And then we also just at the same point generate the QC report in PDF format. So you can see, you have our ephemeris downloads, just a good summary of pretty much all. It has all the plots. Some people attach this to projects. Okay, so now that we talked about the trajectory processing QC, I'll kind of go back to the scan generation and this project that we're looking at here. So all I did on this one was a default filter with the firmware flags. It was just the regular SBET. It hasn't been registered or anything like that. Let's go to color coded so everybody can see. And I wanted to kind of zoom in on a couple areas and just show you that there is separation, because the next step is to match these runs together. So let me go to point clouds, open up a quick limit box. So you can see there's our 2 passes. So at this point we had, if I go down the whole run, the separation kind of varies up and down. There's a few spots where it matches almost right on and then it gets out like this. But I just wanted to show this separation before I move into showing what we do about this separation. Another point to kind of mention at this juncture is how clean this road surface is. That's one of the things we're really proud about with the MX50 is just the low range noise of the data and how clean, nice planar surfaces look. I'll show that a little bit more once I match these runs together, but just wanted to kind of give it a little highlight of the very thin range noise on the road surface with this system. Close this out. Okay, so the next step in this process is to select my runs, and we did a batch register run to run. If we were registering down to ground control targets, which I showed in the last power hour, and I'm sure I'll show many more times in other demos, we would use the register run tool, which goes to GCPs. The run to run tool is what we're going to use for this type of job, where we're just mostly focused on the matching the point clouds. We know their horizontal is within our expected tolerance for this job. We're just gonna do a quick match. Your adjusted run and your reference run are right here. In this case, I only had 2 runs, so it's pretty simple. I'll just take my first run and adjust it to my second run. You just add it to the list. If I had more runs, I can add more to the list and it'll sequentially work its way down the list. So the order of that list is kind of important because if you move a run and then register another run to that one, the order of operations matters. You can update the scans in a single click and open cutting plane view, or you can compute it, see what your values are, and then update scans after. Generally, I'll just update scans right at the same time, but I expected this one to work pretty well. It has good overlap. So what I did on this case is I computed it, made sure that everything looked as good as I expected, and then I'll close this out. What I did there to just save an extra step. There we go. I went into update scans manually and then colorized at that point. So that way I was kind of updating my scans to their final positions and colorizing instead of having to do 2 separate steps. So that's one reason where you would leave the update scans checkbox off in the register run to run tool. If you weren't going to colorize, I would just let it do it in one step. But that is kind of a benefit of doing it separately, is you can knock out the colorization at the same time. Okay, now I'm just going to switch a few things around for 1 second. Just getting another project opened showing the results of that batch register run to run. One thing you can note here on the top toolbar is, since it is MX50 data, the side camera view and the backward camera view are grayed out because the MX50 does not include those additional cameras. Okay, now I have another project open. Let me turn on all the point clouds. Let's turn off all the extra features. So you can see here, this is the result of that run-to-run registration I just did. I'm gonna turn off my default class because I did run a extract classified point cloud regions command to just get some of the vehicles, get some of the extra kind of trash out. I just let it do a quick one, didn't really clean it up any, and just use that as kind of my basis. So my favorite part about that is turning off everything and just doing ground. I like just a nice clean ground surface a lot of times when I'm working. And we'll just zoom in on, I don't know, some random spot here in the middle. That might have been the same intersection I was looking at before. Let's get a nice cross section of that road. Okay, so you can see the nice clean road surface here. And I did show the separation from before. I just kind of want to highlight that there's still multiple runs there. So you can see if I turn off both, there's one scan, there's the next scan, there's the rest of them. And this was fully automated, just let it run down the roadway. And like I said, this is a pretty typical, easy kind of job for the run-to-run tool because you can see how much overlap there is. There's almost the entire roadway of overlap. So this is where we would expect it to work very well, and I just kind of want to highlight how that tool matches everything up. A couple more things to kind of note. I want to talk a little bit about the MX50 data itself. One of my favorite things about it is how clean the intensity returns are. You can see, we have really nice bright road striping with clearly defined edges. And one of the improvements that we made with the MX50 is we increase the accuracy of the colorization of the point cloud. So we actually reduce the range that the images can be used in to try to keep a higher accuracy, so that when you're using the actual true color scans, there's more trust in actually where that color is. Where some colorization in different softwares and stuff I've seen, it's nice for visuals, but I wouldn't pick a target based off of it. We've done quite a bit of work to get these colors to match up with the intensity values as closely as possible. Do a little bit of zooming out so you can see the coloring. And you still have this where somebody gets behind you and you get a little bit of car color on the road surface. Okay. One of the next things I wanted to show real quick was just to open up a run and do the panoramic view. It's the same Ladybug 5 Plus that's on the MX9, so image quality is the same. One of the nice benefits of the 50 is you actually get a little bit better view of the roadway next to the vehicle depending on mounting position, because the MX50 is a little bit smaller of a package, so you do get a little bit better of a downward facing view. Can do all the same stuff here with turning on point clouds and viewing the point cloud from the actual vehicle point of view. We'll jump to just the middle of the run. You can do all your normal tools here. Some people prefer working from these views. So I can run extractions here, mark up the roadway, anything that you would normally be doing can be done from this view. Personally, I work more in the 3D view than from the actual vehicle-based view. Okay, so as far as mobile mapping specific stuff goes, that's kind of where this presentation ends a little bit. The rest of the tools in this toolbar, visualization and reporting and things like that we're not going to dive too much into. The idea of this project was to focus on, getting assets out to a GIS, software of some sort, doing something like a, let's say a city government was collecting all their signs in a certain area or wanting to inventory their poles. That was kind of the idea of test collecting this data, processing it, going through this whole process. So at this point, I'm going to move into the point cloud module and change a few things around. Let me turn on my other regions. So for this project, I did a quick extraction of the signs, the poles, and did some curb and gutter work on this one. And then that was kind of our theoretical test project. There's a lot of power poles on this project, and then also a bunch of these light poles right here. And we coded them all as such. Signs and poles, we're all using this point feature tool. I'll kind of discuss it for a second, but I'm not going to run it. It's been around for a bit. We've made some improvements, but it's generally been the same for a good bit, so many of you are probably familiar with it. I did want to discuss a couple things though with sign and pole and tree extraction. there is a little bit of a tip and trick that I was gonna kind of pass along, is if you leave all of your regions on, it's gonna search through all of your regions. So in a case like this where I didn't do any manual cleanup, you can see, there's some buildings over here that have a little bit of pole class on them, things like that. I didn't do any cleanup here, so I wanted to run the tool on everything. So if there was a sign that was misclassified as a tree, I still wanted to pick it up. If you had done a lot of cleanup and knew that all of your poles and signs were in your pole and sign class, you can turn off these regions, and then the tool will only run on the visible region of poles and signs, and it'll run, multitudes faster because it's going through many less points. But if you had, a pole or sign that wasn't in that particular region, then you might have to worry about that. One of the other things that it will use is the ground class. So if I'm doing a pole or a sign extraction automatically, the ground class is used to help set a base height for the extracted point. So let's say that sign right there has kind of, if it didn't have any returns, or if this pole didn't have any returns on the bottom of the pole, or was light on the bottom of the pole, it uses the ground class to help set kind of a floor to get a better elevation for that pole height. So that's something that some people weren't aware of, that the sign and pole tools work on all the regions, and depending on how you turn regions on and off, it can kind of change how the tool works, both in speed and if you're missing things like this sign over here that got thrown into the tree class because it's kind of bunched up with this vegetation. Okay, so I'll close that tool out. Wanted to turn on the extract line feature tool real quick. Turn on just my ground. And this one, since it's a newer tool, I'll do a quick run of it. Yeah, let's try it over in this section. So many of you might have seen this in different webinars so far. The way the curb and gutter tool works is you can set your line settings. So I might just call that CG. Let's call my layer utility storm, and then you can set your color to however you want it. I actually individually color like top of curb, back of curb, different things. So I'm not going to mess with the coloring right here. You set 2 points as kind of a cross-section view, which I'll do like that. You can zoom in. I'll turn the point size up a hair. Then we're going to set our different nodes. My back, top, bottom. And then sometimes the edge of the gutter is a little hard to see. So one thing I like to show people is you can actually select it in this other view. So in this top view, not sure how it's showing up for everybody on the webinar, but I can actually see that gutter line a little bit more clearly over here. So I'm going to select it from that screen, and you can see it updates down to this bottom cross-section screen too.
Yeah, you can see it, Skylar. And then also, the nice thing too is you can see all of those 4 picks in the 3D view if you zoom in, so you can validate it there as well.
Yep, you can see the little magenta dots right here, and I can kind of turn the angle and make sure everything's lining up correctly. And then you set your interval, your kind of spacing that we're going to be setting, or I kind of think of it as like a chord length of these lines that we're generating. You set a confidence interval where it's going to stop at and have you revise it. And then once it stops, I'll show a couple of these additional tools. I'm going to switch this over to gray so everybody can see it a little bit better. And we'll just run the tool down here to the edge. So it felt that it was outside of the confidence interval. I'll switch back over to color so you guys can see why. You can see this kind of top of curb is falling off of my template a little bit. So I'm going to go in, it automatically selects edit template nodes. You can see our confidence interval dropped down to 86%, which is why it dropped off. gonna take that node, pull it out a little bit. I'm gonna adjust this up just a hair, and then I think I like the rest of it. So it looks like the curb became a little bit more vertical, which is what happened. And then I'm gonna say extract, and we'll continue on. Okay, and you can see right here, this is where I was trying to get it to, where you can see the curb drops down for this crossing right here. So I'm going to edit my template nodes to fit this kind of curved, dropped down curb like that. I'm going to select my next node point, which is referencing node 2, which is this one right here. I want to select right where it kind of becomes flat. I like to use the edge of that, I don't know exactly what the terminology of that ramp would be, that dark ramp. I select right at the edge of that ramp, say extract, go in, edit, make everything flat right there because we no longer have a curb. I'll select my next point, go to the other side of that ramp, extract. Then I'm going to select up the curb a little bit, extract, edit to fit there. And select next, and you just kind of manually do the tapering, let everything change around, edit that. And then once I reach the full height of the curb again, and we're kind of out of this turn, which might be right there. I think we're back to about the full height of the curb. I can just hit extract again and let it start doing its own automatic. And so let's finish that. I just want to show the QC tool real quick. I like to do a smooth curve on most everything. It seems to fit quite well, so I apply it all and then add. Let me turn on that curb and gutter. So you can see I actually already had curb and gutter lines there because there's additional ones hidden right behind. But I like to show this where when everything's kind of nice and straight, we just let the tool do its thing. But there's all these handy kind of manual tools to help it with weird things like these ramps right here, where you have a nice smooth transition down to flat and then back up to your regular curb. So I'll close that. I'm actually going to I'm just gonna kill those because I still have my original stuff. And then at this point, I want to show all of the different features that I've extracted real quick. Okay, so you can see I have, all my signs, which I'll turn on some scan data so we can see it. So you can see, my railroad crossing signs, power poles, more railroad crossing signs, more power poles, and just there's a couple hundred features in here that were extracted. And then at this point, this is kind of where in this theoretical job, I'm handing this off to whether it's a GIS department or a colleague, or maybe I still handle GIS stuff, but this is kind of the transition point. So we have all these features. We have, all my curb and gutter and flow lines extracted, and then all these features. So I'll pull up a little section on the GIS module and kind of hand it off to Jeff and Nicole, who in this theoretical case are the GIS department that I'd be passing off to.
Awesome. Well done, Skylar.
Thanks.
All right. So next up, I want to quickly highlight what's kind of changed in the GIS module the past couple of releases, kind of dating back to version 550 earlier in the year. We really needed to give some attention to this module, to sell this thing, we wanted to have a streamlined approach where we could send data to and from. And then also, if you follow Esri at all, you're very much aware that they're trying to move away from ArcMap and then move towards ArcPro workflows. So what we did in the past was we just had a general connection to ArcMap. And in 550, what we did was we made a connection to ArcPro, which is really nice. In 551, which is our most recent release, what we did there was a lot of our data that we were writing back from from Esri to TBC was just coming in as all white points, white lines, and polygons. So it really didn't mean much to the end user, right? Because usually we like to feature code these things, look at the symbology, identify them with colors, etc. So what we did now in 551 is to acknowledge those feature codes and names and take that symbology right into TBC and populate that again, so that you can see both in TBC and Esri the colorized differences between the two. And I have those kind of highlighted there where we have the same data both in TBC and ArcPro over on the right-hand side, both showing in the correct location, actually taken right from our tutorial data set. So if you have any interest in doing this and following this workflow, please go to our website and check that tutorial out. I wanted to quickly highlight some of the general mechanics of the TBC connection in itself. It's essentially two providers, one for ArcMap and one for ArcPro. And then, essentially utilizing this enterprise geodatabase connection is the bread and butter of this piece, sending over points, lines, polygons, etc. You do have the option to use shapefile connections and file geodatabase, but I think overall, if you're using GIS workflows, you're going to want to use the enterprise geodatabase connection. For today's demo, Nicole's going to do the file geodatabase just because enterprise is a little bit slower in a live demo, but she'll highlight the reasons why there. And then just kind of looking ahead, what we do want to do is have more of a direct connection towards featured services and other Esri connections as well. So more to come with the GIS module, but I think we made some really good changes to help you guys out in making more of a seamless connection from TBC to Esri, and then also from any changes that you make from Esri back to TBC. And Nicole is going to highlight that now.
Awesome. Thank you, Jeff.
Just switching you over right now.
Are you guys able to see my TBC screen?
Looks good to me.
Okay, sounds good. So thanks again, Jeff, for explaining all that. And I'll just be picking up where Skylar last left off. So here I have the same TBC project open on my end, and I've turned off the ground scan just so that the points and line work are a bit easier to see. So I've also imported an FXL just so that the points and line work have some symbology retained. If I zoom in a little bit, you'll see that the power poles are these yellow lines here. If I select the point in the properties pane here, you can see the feature code, the layer name, and the height and diameter, which are its feature attributes. Same with this little sun symbol here. This is a light pole. You also see the height and diameter under feature attributes as well. And for signposts, you can also see height and diameter, and these ones actually have a sign type. Currently, all of the signs are set to other, but I want to show that reading and writing data between TBC and ArcGIS Pro actually retains these attributes. So for the sake of this demo, let's go to, let's say, this top signpost here, and change the sign type to a stop sign. And just for good measure, let's change the second signpost down here to a yield sign. So now that we've done that, let's zoom out a bit and go back down to the line work that Skylar just extracted. You'll see that there are 4 lines here, so top and back curve, which I've had in gray. You can see the feature in the properties as well as back curve. You might not be able to see it, but the flow line is here in dark blue. Again, you can see the feature as flow line, the color is dark blue, and this nice cyan line is the gutter. So now that we've gone over that, let's get straight into reading and writing data between ArcGIS Pro and TBC. So what I want to do first is I want to go to the Home tab up here and open the export command. This will open up on the right side for me, and I want to select the GIS tab. Now, before moving on, I do want to say that you can just export your data as a file geodatabase right off the bat. Read that into ArcGIS Pro and then play around with that. But for the sake of this demo, I do want to show the reading and writing of data using these GIS commands here in GIS Ribbon. Read features from GIS and write features to GIS. So I actually want to just import a schema into my geodatabase for now. This will be able to kind of show the linking of data and avoid duplicate data, which we'll see a bit later. That being said, I'll select Geodatabase XML Exporter first. I'll select all of my data, and I'll choose a place to save this to. So I do have a folder called TBC Exports, and let's rename this to TBC_XML. I'll hit export at the bottom now. And as you can see, that was really fast. So I'm going to quickly switch to ArcGIS Pro now. So here I have an empty project, and if you look at the catalog pane on the right here, you'll see that there was actually a database already created with the same name as my project. ArcGIS Pro does that automatically, so I'll be using this file geodatabase. I'll right-click this geodatabase, select Import, and select XML Workspace Document. And here I can see my target geodatabase, and for the import file, I want to maneuver to where I just exported that XML file. So I'll go here, August Power Hour, TBC Exports, and here is my TBC-XML file. Hit OK. And under Import Options, if you drop this down, you have the option to import both the data and the schema, or the schema only. As I mentioned earlier, I just want to import the schema for now because I want to use that write-out command from TBC. But if you want to import the data and schema and then ship that off to the ArcGIS website, you can also do that through this method as well. So I'll select Import Schema Only and hit Run. This should only take a few seconds. It's relatively fast. And as you can see at the bottom, it's finished up. So I'll close this window. And now if I right-click this GDB and hit Refresh, we'll now see the features that were created in TBC. So we have our back curb, flow line, gutter, light pole, power pole, signposts, and top curb. You'll notice that there are these two other layers called lines and points. These are just layers that contain all of the line work and all of the point work. So I won't be reading these in later on, but just wanted to point that out. So going back to TBC now, I want to go to the GIS tab up here and select GIS Connection Manager under the Connection tab. This will open up the GIS Connection Manager on the side here. And you'll notice that I already have two connections. This was just to read in the line work and points that Skylar just extracted. So I'll create a new connection. And let's call this ArcPro-GDB, just so I can keep track of where I want to write this data out to. Under the data source type, you'll see Shapefile, File Geodatabase, and Enterprise Geodatabase. Jeff mentioned earlier that the Enterprise Geodatabase might be the more sought after option in terms of GIS connection. These are good for, I guess, larger organizations who want to share data more freely or collaborate on a geodatabase with more ease. So if that's what you're interested in, definitely look into this. But for the sake of the demo, I'm still using a file geodatabase. I'll select Connect, and I'll go to where I've saved that ArcGIS Pro project. So August 25th. Oh, sorry. Demo Neo, and then here is my GDB. I'll select this folder. Hit OK. And then I can go straight into writing features to GIS. So you'll notice that I just clicked on an icon in this little tab here within the command. If you see that I'm hovering over the icons, you can see what command that is. So this is read features from GIS. You can also access the same commands in the GIS ribbon at the top here. So this is where write features to GIS would be. That being said, let's get back into the command. I want to make sure that I have the right GIS connection selected. So ArcPro-GDB, that's good. And in terms of writing out data, I don't want to do everything all at once. Let's say for the purpose of this demo, I just want to write out the top half of this project. So the line work seems to end here. I'll write up I'll write out this data here. And here you can see all the features that I have in TBC, and currently everything that I have selected is under the new column. This is because, again, we haven't written anything out to the GDB yet, so nothing is underlinked, and we're going to fix that now. So I'll hit OK, and this will ask me to generate a report. Here you go. I'll say yes, and this report just basically goes over what features were written out, how many objects of those features were written out, and if anything failed, you'll be able to see which features failed. So it'll also show you your coordinate system, and scrolling down a bit, you'll see the different feature types here, how many objects were selected and written out. And at the bottom, you can see write succeeded, 131 objects, write failed, 0. So it looks like everything worked nicely, and that's great. I'll close this report out now and switch back to ArcGIS Pro. So here, I'll just refresh my GDB and select all of my features, exclude points and lines like I mentioned before, right click and hit add to current map. So as you can see, the data is still coming in, but we are along Hover Street. If you go back to TBC, that should be where we are at as well. So that means that the data came in at the right spot, which is nice. So zooming in, you see Hover Street as well and Pike Road. So it looks like it's in the right spot. Now, if you recall, we changed the signpost types for these top 2 points up here. So I'll just check the attributes. It'll open up this pop-up pane. You see that the signpost feature was retained. You see that the height and diameter feature attributes are also retained, and the stop sign type is also here as well. For good measure, I'll check the second point here that we changed, which should be yield, and we see the same thing here as well. So now that we've done that, let's write out the rest of those points from TBC. So as you can see at the bottom, I have this empty space here. Let's write out the rest of these points. So again, I'll go to the write features to GIS command up here. You can also access that through the little ribbon in the command. And I want to make sure I have the same connection selected, which is still ArcPro. That's nice. And under select data to write out, I could either select all of this data that I know is new, which you'll see here under the new column. However, if I select all of the data in my project, you'll see we have still the new objects, but also the linked objects as well. This is nice because it avoids duplicate data in the GDB. That being said, I'll hit OK and have this write out to that BioGeo database. It'll ask me if I want. Oh, yeah, go ahead.
Here, Nicole, is once you set up that schema like you did the first time, you can just you're ready to go and you're connected, right? You can write these features without having to do that schema again.
For sure, it's just a one-time thing.
Perfect.
Thanks, Jeff. So I'll say no to opening the report again because we've already seen it earlier. And if I go back to ArcGIS Pro and give this GDB a refresh, we should be able to see the points come in. Oh, there we go. Might be a little bit glitchy, so I'll just turn on and off these layers. And there we go. So everything's in here now. Again, you can look at these points as well, and they will retain the height, diameter, and for signposts, they'll have a type as well. Like I mentioned before, all the signposts are set to other, so that looks good to me. So now that we've seen the writing of data from TBC to ArcGIS Pro, let's show the reading of data into TBC. So what I'll do is I'll create a some line work in ArcGIS Pro and read that into TBC. I'll do that by going to the Edit tab up here. I do have snapping on, and I'll hit Create Feature. Looking at this map, we see that there's kind of like some line work missing between this area here and this area here. So for example, let's say I want to create a gutter line to kind of connect those two lines. I'll select gutter, and I'll snap to the gutter endpoint here and the gutter endpoint here. hit OK. And now I've created some line work with the gutter feature. I will save my project and say yes to saving these edits. And now if I go back to TBC and select the read features from GIS command, have that same connection selected, give it a second to load up, you'll see all of the linked objects that I currently have. And under gutter, you see that there's one new object, which is the one that I just created in ArcGIS Pro. So that looks good to me. I'll hit OK. And I do have everything selected right now, so it's all orange, but we briefly saw that little cyan line. I'll zoom back in. And you'll see that we have that gutter line connecting the previous gutter line and this other gutter line here, and it comes in as cyan as well. If I select this feature, you'll see that in the properties that it is feature coded as gutter as well, and that's why it is colored appropriately. So that looks great. I'll go back to ArcGIS Pro now. And let's say, for example, you want to change the symbology in ArcGIS Pro because currently everything is just like a point with color. It's a bit hard to tell what's what without clicking on it. You can definitely do that by selecting the symbol here in the contents pane. And that'll open up the symbology command, and it'll give you the option to change that up. I've actually done this prior to the demo just to kind of save on time, so I'll pull this over here. You can see that I changed signposts to these red diamonds, power poles are these brown circles, and light posts are these orange hollow circles. Again, these have their attributes retained, so I'll check that stop sign. You see the same thing, so that looks good. Now, one thing that you can do with this data is to give it to a client or share it with a colleague as a deliverable. You can do this by going to the Share tab at the top here in ArcGIS Pro and select Share as Web Map. That will open this command on the side as well, and it'll give you the option to edit your map details. So you can enter in a name, a summary, some tags to make it easier to find. For this demo, I want to copy all of my data over. And you can share this again with the public, within your organization, or just with yourself, which is not checking any of these. Then you would hit Analyze to see if there are any issues with posting the map first, and then hit Share once you're done with that. I've actually done that prior to this demo, so I do have that ready. Let me just go to my contents page in the ArcGIS website. So I called this map MX50 data-demo. You'll see that a web map was created, as well as a feature layer and a surface definition. You can see that I shared this with my organization, so other people within Trimble can see this map if they want to. And yeah, so I'll open this in a new tab. Here you'll see the different features under the layers that we had in TBC, my description, my title, and if I scroll down, here are some tags that I added. So TBC, mobile mapping, demo, and so on. Everything looks good to me, so I'll go ahead and open this in the classic map viewer. And this will retain the symbology from ArcGIS Pro, and it'll also retain, again, the feature attributes from TBC. So let's go to our trusty little sign point at the top here. You can again see the height, the diameter, and the type of sign, which is stop. And again, for good measure, we'll check that second one, which is yield, and we see the same thing. I think that concludes my part of the demo. I'll pass this back to Jeff now.
Awesome job, Nicole. Thank you.
Mm-hmm.
Let me share mine. And give me a confirmation once you see my screen.
Good now.
Okay, cool. Next thing up I want to talk to you about, I want to kind of race through this so we can have a little bit of time to answer some questions. As always, we have these TBC resources available for everyone here. If you just go to our TBC website or the support tab, you can access all of these resources. We have a ton of information for you guys. So please check that out. The resources PDF presentation is something I do want to highlight. It's something that's relatively new, and we update every single month with new content. And everything's packaged up into one presentation there with hot links for you guys to check out multiple different things. Our YouTube channel is always growing. There's hundreds of videos, so you can go on there and learn. You can troubleshoot. Please check that out. We also have a sample data site. So right now, if you wanted to look at MX50 data, you can go to the Trimble Geospatial site, click on the sample data website or link, and go ahead and download MX50 data and drag and drop it right into TBC.
And it's actually that project that I was just showing, just so you guys know. That's the one that I put up as the sample.
Perfect. Thanks, Skylar. And then next up, we have the e-learning. So basically being able to learn TBC virtually, online, on demand for free. Highly recommend you go in there and check it out. It's kind of a simulated approach, so it kind of guides you along the process, where to click. If you clicked in the wrong spot, kind of hints it to where you want to go next. So check that out. I think there's some certificates there that you can actually print off and give to your boss or your colleagues and kind of prove that you took the class as well. So good content there as well. We also, again, I want to highlight this resource PDF presentation. You can see that all the 3 subjects that we kind of generally covered today with GIS workflows, mobile mapping, point cloud feature extraction, you can see all of the content that's already linked in that presentation in each individual topic. So we have things built out for tutorials, previous power hours that are all associated with mobile mapping, YouTube videos that are associated, any tips that we put out for tip of the week, and any sort of documentation that's important with product bulletins. Please feel free to check that out as well. What's next? So the September Power Hour is a topic we're going to do on tunnel convergence monitoring. Again, we'll have Riley Smith cover that, and then also Nicole Lim. So if you really enjoyed this Power Hour like I did, you want to tune into next month because she'll cover tunneling. She does a great job. The topics around this will be kind of tunnel convergence and why is it important, the tools and techniques for collecting the data, tying in the Trimble Access monitoring app within the TBC workflow as well, and then also the TBC workflow for managing the monitoring data itself, and creating customized deliverables from there, and of course taking some Q&A at the end. All right, well, thank you, everybody. Do you have any questions? Let me pull up the questions pane.